Sanger sequencing relies on chain termination to operate at all, meaning that the artificial existence of DDNTPs is vital to this process.
In our magical, mystical, wondrous metaphor, polymerase is glue. That part is easy. We can think of matched cards in a line shown hence. And it's not too much of a problem for the brain to imagine. The cards are held together by glue, the reds match with black, the spades with diamonds, the hearts with clubs, yada yada yada, and so forth and so forth. But chain termination. Why would our lovely matching game come to an end? It's important to note that each DDNTP corresponds to one of the original DNTPs. They each get a corresponding buddy, per se. Since structure and correspondence are the two main points of a DDNTP, in card terms, let's say they are the ace. The ace of spades is the chain terminator for the diamond it should be matched with. The ace, as a card, was originally the lowest, standing in for the common member of society. A DDNTP, similarly, would be unwanted in the natural world, wouldn't it? If it did occur, it would stop a DNA strand from ever properly finishing. Think for only a moment of a DDNTP as a lead-poisoned 1960s era child. Unwanted, unfinished, improperly developed, so forth and so forth. Don't take this out of context. However, for Sanger sequencing, the ace, aka our DDNTP, is vital. Just as the ace, now more often considered the highest ranking card in many games due to the societal change after the French Revolution and overthrowing of the king, becomes grandeur and shining in the hands of a blackjack player. So, with all that symbolism and background, the overlaying concept holds true, with somewhat better scaffolding, that the DDNTPs are represented by the ace of each suite of cards. This part is harder to create in an ideal metaphor, but it can be seen as a game to play within our metaphorical deck of cards. We already know how each suite matches up: spades to diamonds, clubs to hearts, aces to the corresponding suit terminate the chains of S, D, C, H. Glue acts as the binder between each connection. Our radioactive tag sits on each DDNTP. In our metaphor, let's say that each ace has a mark in the white space that's written in invisible ink and can only be seen with UV. Now that that's sorted out, we can simply sort our card chains by length, emulating what would usually be done by electrophoresis. Then take out a little UV light to see each quote-unquote radioactive marker, aka our invisible ink. We pretty much have finished our ideal metaphor, but of course there are still more things to explain about the Sanger method. My last comment on this makeshift card game would be that the objective of it is to find the most time-effective method of sequencing, hence why it is adjusted over time.
Later on, other improvements were made, like the advancement of using capillary electrophoresis or using TAQ enzyme instead of polymerase. These improvements can be read more about on websites like ResearchGate or the NIH, the National Health Institute websites. Today, we do not have time to cover them. Sanger sequencing, both modernized and original versions and iterations, are still used today for projects, especially in those with fewer DNA samples because it can be faster for smaller sample sizes.
Cost. Because of newer technology that has made it easier and faster to sequence DNA, the price has dropped drastically, going from millions of dollars to now as cheap as $600 to $1,500, depending on how in-depth and what kind of service is needed.
We hope you enjoyed this painstakingly done project and presentation of DNA sequencing. Let us know in the comments if the idea and mental image of a deck of cards was useful or not in helping to register this information.